right, boys and girls? So now that you've had the opportunity to practice some multiplication involving two-digit numbers by two-digit numbers, we're going to look at this problem together. The problem says Target ordered 13 boxes of baseball cards. Each box contains 24 cards. How many total cards are there in all the boxes? All right, so when I read my question, how many total cards are there in all the boxes, I want to go ahead and turn that around and say there are blank cards in all the boxes. And so in order to be able to figure out that information, I'm going to need to know some information about the cards and the boxes. So when I go back to my story, I can see that I have 13 boxes. So I can just quickly sketch 13 boxes, and no, I'm not going to make all 13, but I can just quickly sketch that out. Box 1, 2, 3, and 13. And in each one we have 124 cards, 124 cards, 124 cards, and 124 cards. So just by looking at that, I can see that I have the same pieces being put together over and over and over again. So the action is putting together equal sets, which means that we're going to be multiplying to find the answer. Remember, multiplication is a faster way to put things together. It's more efficient. So the next thing that I want to do is I want to move over here to this area. It does say an area model, but I'm going to cross that out because at this time what I'd like to do in this box is make an easy estimate. An easy estimate to see if it's even reasonable. The numbers that we're going to be multiplying together are 124 and 13. So when I think about the number 124, obviously an easy estimate for me would just simply be rounding this to the nearest 100 and rounding this to the nearest 10, which would get me to 1,000. The problem is when I look at this number and I lower it by 24 and I lower it by 3, I can see that this is going to be a low estimate. So anytime that I see that I've lowered it that much, I always look to see if there's something another way I could maybe estimate this and get another number that might be a little more accurate. So 124 is pretty close to 125. And I could multiply that by 10. And then I could get 1,250. So that might be a little more accurate, thinking about I'm only 1 away from 124 and I'm 3 away from 10. So that's an example of how you can do some easy estimates, and then it just gives you kind of a range. Okay, I know that I'm going to be at least 1,000, but probably more like 1,250. Now what we're going to do is we're going to look in this box that's called the partial product. So we're going to extend what we know about two-digit numbers to our three-digit numbers. So we're going to take the number 124 and we're going to decompose it into 100 plus 20 plus 4. And we're going to take the number 13 and we're going to decompose that into 10 and 3. So we're going to multiply these numbers together. And remember, when we're multiplying, we always want to relate it back to those easy facts. So if we know 100 times 1 is 100, then we know 100 times 10 is 1,000. We know 20 times 1 is 20, but we know 20 times 10 is 200. And we know 4 times 1 is 4, but we know 4 times 4 times 10 is 40. Taking those three numbers together and quickly, we can say 1,000 plus 200 plus 40 is 1,240. Now let's go ahead and multiply this next row. So if I know 1 times 3 is 3, then I know 100 times 3 is 300. 2 groups of 3 is 6, so 20 groups of 3 is 60. And 4 groups of 3 is 12. So if I quickly put those together, 12 plus 60 is 72, and 72 plus 300 is 372. Now that I have my two partial products, I can quickly put them together, and that's 2 and 11, and the 5 plus 1 is 6, and 1 more makes 1. So that is 1,612 cards. So another way to look at this, boys and girls, is now to use the traditional algorithm. Whenever I'm using the algorithm with numbers, it's a habit for me to put the one with more digits on top. So I'm going to start with 124 on top, and we're going to multiply that by 13. And so whenever I'm multiplying this, I like to just cover up the number 1, because that really means that we have 124 3 times. So we're going to multiply that 3 by the 4, by the 2, and then by the 1. So we're going to take turns. So 3 times 4 is 12. So we're going to record our 2, but carry the number 1 to the next place value. 3 times 2 is 6, plus 1 more makes 7. So that gives us 72. Or that just gives us 7. And then 3 times 1 is 3. So that total, that partial product total, is 372. Cross out your 1, put your 0 down, and we're going to multiply by the 1. So the reason why we're putting this 0 down is because this one really has a value of 10. But it's much easier to multiply by 1 every time instead of the number 10. So we just put that 0 placeholder down so that we can multiply quickly. So 1 times 4 is 4, 1 times 2 is 2, and 1 times 1 is 1. And we're going to put those together, and we get 2 and 11, and 5 plus 1 makes 6, and 1 plus nothing makes 1. So we get the same number, which is 1,612. And when I go back and think about, is this reasonable? When we knew that this answer would be over 1,000, we felt like 1,250 was still going to be a low estimate. So I would say yes, this is a reasonable answer, 1,612 cards. So I'm going to go back and put that in my box. And that's it, boys and girls. That's how we're going to multiply 3-digit numbers by 2-digit numbers. Now what I want you to do is go back into your jam, and I have some practice for you to complete in Schoology.